Hello everyone, and today we will solve this problem. So we have this problem from I think from calculus. Okay, so we have to find the limit of as x tends to 0 1 by x integration 0 to x e to the power sine t dt. So that limit we have to find. Okay, so at first write this function for which we have to find the limit. Okay, so the function is this. All right, so that is a function. Now the limit is actually x tends to 0. So if I put x tends to x0 here, so that part actually becomes undefined, and that part actually becomes 0, because 0 to 0 the limit becomes equal, so the integral will be 0. Okay, and that part becomes actually undefined. Okay, so from here we can construct certain things so that we can find the limit over here. Okay, so we write that function in a different pattern. So let's see what happens. So we write the exact same function like this, so in the rational form. So 1 by x means we can write x on the denominator, and then the main function or the integral function over here. Okay, so now you just take the limit. Okay, so now if you see that the lower part becomes 0 and the upper part also becomes 0, so this means this is a form of 0 by 0. Okay, so 0 by 0 means, of course, we have the Lhospital rule, means we can do the derivative of the numerator and denominator. Okay, so we see that derivative of the lower part is very easy because its derivative is 1. But what about the upper part? Okay, so upper part is an integral part. So if we try to derivative this, we have to apply the derivative under sign of integration, which is called the limit derivative. So let's derivative the upper part. Okay, let's see what happens. So in the upper part we see that we have to do this ddx of integral 0 to x. Okay, so we have to do this. So what is that? We see that the upper part is basically, the upper limit is x and lower limit is 0. So lower limit is constant, so we don't bother about the lower limit. We only concentrate our mind on the upper limit. So upper limit is actually direct x. So what happens when you derivative this? And also you can see that the integrand, in integrand there is no x, so that is quite becomes very easy. So we can directly derivative is like that way. So it will be like this: e to the power sine x into, so e to the power sine x means if the integrand is fx, so this becomes ft, so this becomes fx. Okay, then we have to do the derivative of the upper limit, which is x, so dx by dx means 1, so into 1, this means that is e to the power sine x. Okay, so this limit becomes limit x tends to 0. So limit x tends to 0, so the upper part derivative is e to the power sine x and the lower part is 1. Okay, so of course this limit becomes when we put x equals to 0, because this now becomes a very finite type of situation. So this becomes e to the power sine 0 means 0, so e to the power 0 means 1. Okay, so basically in most of the cases, if the form is 0 by 0, it becomes like 1 or something like that. Thanks for watching.